they find $100 on the ground or something, or they get a raise at work, or their husband gets a job, or they have some positive shock to their income. Yeah. What part of the model will change?
The budget constraint.
Yeah, the budget constraint will change. Yeah. Finding $100 on the ground does not make you like coffee more or like donuts more. Like the indifference curve shouldn't change. The action's going to be with the budget constraint. It'll shift outward. You can afford more stuff. Will the slope change? Or will it just be a level shift out?
Just be level.
Yeah, right? Because the slope of this thing, remember, is the ratio of the prices. Yeah, and I didn't say anything about the prices changing. We'll do a lot with the prices changing momentarily. That's probably the more interesting set of results, right? But for now, we're just saying, hey, the relative price of coffee and donuts didn't change, therefore the slope of the budget constraint didn't change. It just shifted outward. Yeah. Okay. So I don't know. It shifts outward, something like this. You're no longer maximizing at C star 1, D 1 star. You can do better now, right? You can move to an indifference curve that's further out. Yeah. So the consumer will move out and move out and move out and keep moving out all the way till they get to the point where the furthest out indifference curve they can reach is exactly tangent to the new budget constraint, and their new utility maximizing bundle is D star 1. I'm sorry, 2. C star 2. So they recalibrate, something changed. Their income changed, and they have a new utility maximizing bundle. As I've drawn it, can we say something about coffee and donuts? Or that's a vague question. Is coffee a normal good?
Yes.
Yeah, because when their income increased, they bought more of it. That's the definition of a normal good. Are donuts a normal good?
Yes.
Yeah, because D star 2 is greater than D star 1. Yeah. That need not be the case, of course. Right? I could draw a diagram, and I will right now, where there's a level of shift out in the budget constraint, but given the consumer's preferences, it causes them to consume less of one of the goods. So you could draw this with an inferior good, although the diagram is slightly, more tedious to draw. But I'll do it. I'll do it anyway. So yeah, that was a normal good. Let's consider an inferior good. And now I need to be careful with the diagram, because sometimes you need to draw these just so to get what you want. Okay, so you have some initial budget constraint, some initial indifference curve that is tangent to that budget constraint, say here. This is still coffee and donuts, and you have C star 1, D star 1, that's backwards, sorry. Okay, and then same idea. The consumer finds $100 on the ground or something. Their budget constraint shifts outward, but the slope doesn't change. Something like that. Yeah. They're no longer maximizing at C star 1, D star 1. They can move to a further out indifference curve. I'll try to draw a new indifference curve that is roughly parallel to the previous one. Yeah. Although it's going to be a bit of a reach. So maybe they move out to this indifference curve, which, is roughly parallel to the old one. Yeah, your book has much more beautiful diagrams of this kind of thing, drawn with a computer, right? But the point is they get to this new utility maximizing bundle on a further out indifference curve. At the new one, they're consuming more coffee. Coffee's a normal good. Yeah? But they're actually consuming fewer donuts. Yeah? Donuts in this case are an inferior good. Yeah, so it just depends on the slopes, the shapes of the indifference curves, right? You can have the budget constraint change in the exact same way, right? But for particular shapes of indifference that is particular sets of preferences, right? You could have an increase in income lead to a decrease in optimal donut consumption. Yeah. And intuitively, if you get a big raise at work, you might eat, less ramen noodles or something, right? Like we talked about early in the class.
When you draw the second indifference curve, does it have to be at that specific point along the budget constraint, or can you kind of put it wherever you want?
No, I could have drawn this I could have drawn it like that.
Yeah.
And then coffee they both would have been normal goods. I drew it this way to demonstrate the idea that you could have an inferior good in this framework. Yeah. It seems like a stretch, the way I drew it, maybe. But there's nothing that prevents that. Yeah. When I taught this on Thursday, there was a lot of questions like, well, what if you have 3 goods or something like that? Or what if you have 4 or 5 or n goods, which you obviously can't put on like a 2-dimensional graph. I noticed when I came in that this must be from intermediate micro. So this is actually, somebody just left this on the board. But it's the same diagram, right? But they're just doing it with math, right? And so what you would do, in a more sophisticated class, in a more advanced class, is you would maximize some utility function. It's like, 1/2 the square root of coffee plus 1/2 the square root of donuts or something, subject to some, to some constraint that reflects the prices and incomes. And you would just do that with math, right? You'd write out, and you could do it with n goods or whatever. You wouldn't have to draw any diagrams, right? So you characterize the preferences with a function, not with a picture. Yeah. And when you do it that way, like when you're doing it all with pictures, because it's an introductory class, sometimes the pictures are you have to draw them in a very specific way to get what you want. Like in this case, I wanted to draw a picture that had a reduction in donut consumption after an increase in income, and you have to draw the indifference curves very flat and blah, blah, but in general, you can model this in a more, a more general way that isn't dependent on drawing indifference curves just so, right? So yeah, if you take intermediate micro, this is what the boards will look like, but the underlying idea is the same. And there's lots of fun math. It's constrained optimization, and you can do stuff. So it's a big mistake from a videography perspective. Back them roughly, yeah. Okay, let's think about a set of more interesting cases, in particular when there's a change in the price of one of the goods. Yeah. So let's see. Let's think about optimal donut consumption when the price of donuts changes. So that is, the change in demand for donuts when the price of donuts themselves change, rather than what we'll do in a minute, demand for coffee when the price of donuts changes. So I'm talking about a change in the price of the good itself here. Yeah, the good under study. That's a common point of confusion in this. So, yeah. Say we have some setup. There's a budget constraint. This is coffee. This is donuts. Yeah. There's some optimal, there's some indifference curve that leads to some optimal level of donut consumption, D star 1. To keep the picture clean, I'm not going to label the coffee levels, but they're there. Yeah. Okay, and then say the price of donuts goes up. Yeah. How does the diagram change? Yeah.
It's going to change the slope of the budget constraint.
Yeah. And in particular, it's going to kind of like pull this intercept inward. Yeah, so it'll get steeper. And you know, another way of saying that is like if you spend all your money on donuts when they were relatively cheap, you could have bought this many. And after the price goes up, if you spend all your money on donuts, you can only buy, you know, this many. Right, so this intercept will go in. You have a new budget constraint like this. Yeah. It's a bummer. You can no longer, you know, consume this bundle. You're going to end up on some worse off indifference curve, right? The number of donuts the bundle you were consuming before is no longer feasible after the price of donuts went up. Yeah. You're going to have to shift in. So I'll try to draw another indifference curve that's just roughly parallel to the original one. Something like that. And so after the price of donuts goes up, the consumer recalibrates their optimization process, and they end up at a new optimal level of donut consumption, D star 2, which is less than the original one. Yeah? That seems like an unremarkable result, but actually it's kind of important, right? Because let's say I want to draw a new graph where on the vertical axis I had the price of donuts, yeah? And on the horizontal axis I had